So far, we've discussed the three different firewall architectures: bastion host, screen subnet or DMZ, and multi-homed. Now let's take a look at the various types of firewalls. You can classify firewalls into many types, but for our discussion, we're going to talk about packet filtering firewalls, circuit level gateways, proxy firewalls or application level gateways, and stateful multi-layer inspection firewalls. We'll briefly talk about each of these.
Now to start with, let's take the packet filtering firewall. This firewall looks at each of the packets that pass through it. It will decide whether to pass the packet toward the destination or to drop it. Now the name says it all. Packet filtering firewalls look at individual packets. However, packet filtering firewalls cannot look at just the header information. They must look at the entire packet, then make a decision.
That's right. And before talking about the other types of firewalls, we need to discuss what traditional packet filters look at in order to make a decision. They look at the source IP address, the destination IP address, the source TCP UDP port destination, the destination TCP UDP port, the TCP code bits, protocol used, and the direction of the packet, whether inward or outward. The source IP address is used to check if the packet is coming from a valid source or not, and can be found from the IP header of the packet. And it's going to have the source system address in it.
And destination IP address is used to check if the packet is going to the correct destination. It checks if the destination accepts this type of packets. You can also check the source and destination ports to decide on the service to be allowed and the services that have to be denied. You can use TCP code bits to check if the packet has the SYN, ACK, and other bit sets, and to decide what to do based on the settings. You can also check if the protocol should be allowed. Now, what does this mean? This is because there are restrictions on the protocols to be used. Some networks don't allow the UDP protocol. You also will check if the packet direction is inward or outward. You can also check the interface to figure out if the packet is coming from a reliable source or site.
That's right. Now, circuit level gateways work at the session layer of the OSI model, or between the transport and application layer of TCP/IP. Handshaking between packets will be monitored to determine if the requested session is genuine. You have session rules, and you can use them to control the traffic to only recognized computers. Any information passed to a remote computer through these gateways appears to have originated from the gateway. The incoming traffic carries the IP address of the proxy or the circuit level gateway. Individual data packets are not filtered. These conceal the network from the external world. These types of firewalls are relatively inexpensive.
Yes, and next we have proxy or application-based firewalls, and they focus on the application layer, not just the packets. They analyze the application information to decide whether to transmit the packets or not. A proxy-based firewall asks for authentication information before passing the packet. A variation of the proxy-based firewall is a content caching proxy. The content caching proxy optimizes performance by caching frequently accessed information. Instead of sending new requests for the same old data to the servers, it caches the most frequently used data.
The last type of firewall we should be familiar with is the stateful multi-layer inspection firewall. These firewalls combine the aspects of the other three types of firewalls. They filter packets at the network layer to decide whether the session packets are legitimate or not. They evaluate the contents of packets at the application layer. Now, you remember that the packet filter firewalls have the ability or inability to check the header of the packet. That is overcome here. This type of firewall can remember the packets that pass through it earlier, and then will make decisions about future packets based on the states it remembered. These firewalls provide the best of both packet and application-based filtering. Cisco PIX firewalls are stateful. Stateful multi-layer inspection firewalls track and log slots or translations.